Assalamualaikum warahmatullahi wabarakatuh to Mr. Afizal and Dr. Ibrahim. We are from Group 3. In this video, we will show you how we conduct the experiment based on second law of thermodynamics. Members of this group are me, Siti Zahrami binti Abdullah with matrix number 73839, Gloria Lourdes Walter Duhan with matrix number of 73472, and Siti Haja binti Muhammad Juri with matrix number of 73829. The content of this video is introduction, objectives, hypotheses, materials and equipment, procedure, safety and precautions, results, discussion, and conclusion.
So for the introduction, the experiment we did is based on the second law of thermodynamics, where it states that the heat will naturally flow from hotter to a colder body. And second law of thermodynamics, in terms of entropy, states that the entropy of an isolated natural system will always tend to stay the same or increase. This experiment looks at why a pot of boiling water suddenly stops boiling when an ice block or when water of different temperatures are placed in it. A pot of 500 ml of water is heated on a stove until it comes to a steady boil. Then, 125 ml of hot water, 125 ml of lukewarm water, 125 ml of cold water, and ice block of 125 ml are put into the pot. Water will immediately stop boiling. This experiment likewise proves the second law of thermodynamics, demonstrating that the heat from the burner of the stove will always flow from the coldest object in the pot, which in this case is the different temperatures of the additional water as well as the ice block. Therefore, the heat from the burner stops making the water boil, as it instead works to make the additional water of different temperatures to be hotter and the ice block to melt and become water. The objectives of this experiment are to determine the time taken for water to reboil when added with water with different temperature, and to determine the change of entropy. And as for the hypothesis made for this experiment are higher temperature of the added water into the boiled water will have lesser time taken for it to reboil, and two waters with large temperature difference will have large value of change in entropy.
In this experiment, the materials and apparatus needed are 500 ml of water, 3 sets of 125 ml of hot water, 3 sets of 125 ml of lukewarm water, 3 sets of 125 ml of cold water, 3 sets of 125 ml of ice, stoppot, gas stove, thermometer, and stopwatch. As for the methodology, the general startup procedure was the stoppot was filled up with 500 ml of water. The water was allowed to settle for a few minutes. Any leaking was checked. As for the experiment, the first step was 500 ml of water in the pot was boiled on the gas stove. Second, measured the temperature of 125 ml of hot water and poured it into the same pot. Third, the time taken for water to reboil was measured using stopwatch. The data was recorded. Fourth, step 1 until 3 were repeated. Fifth, step 1 until 3 was repeated and the hot water was replaced with 125 milliliter of lukewarm water, 125 milliliter of cold water, and 125 milliliter of ice. As for the general shutdown procedure, the gas stove was turned off after the experiment. The liquid was drained out from the pot after use and cleaned before store. For the safety and precautions, we need to always wear material clothing and shoes throughout this experiment. Stove presents fire hazard. Therefore, do not let flammables such as notebook near the area of stove. The boiling water could burn. Therefore, make sure the hands are in a safe distance when pouring additional water of different temperature into the pot. Never leave hot pot using bare hands. After the experiment was ended, the hot water is cooled down before discarded into the sink.
This is the experimental data from each group members compiled in the table shown. Each of the experiment was repeated 3 times, so the average initial temperature of added water and the average time taken for water to reboil were calculated. The experimental data in the table before was put into a bar chart. As you can see, there is a slight difference in the data obtained from each of the group members, but generally the trend is the same. For the calculation, we are going to calculate the change of entropy. In order to do that, we need to calculate the heat Q first. By using the formula, heat Q equals to mCt, where m is the mass, C is the specific heat capacity, which is 4.18 joules per gram degree Celsius for water in liquid form, and 2.11 joules per gram degree Celsius for water in solid form, and T is the temperature in degree Celsius. In this case, we are going to use the average temperature. After that, we can calculate the entropy. The formula used is entropy S equals to Q over T, where Q is the heat calculated and T is the temperature in Kelvin, which is 368.15 Kelvin or 95 degrees Celsius. For this experiment, the change of entropy for each type of water will be calculated by using the formula. The change of entropy delta S equals to S2 minus S1, where S2 is the entropy of the boiling water in the pot and S1 is the entropy of the water being added into the pot. The change of entropy calculated were compiled for each of the group members in the table shown. This is the graph of average time taken for water to reboil versus the change of entropy from the previous table. From this graph, we can observe that all of us got similar result and it follows the same trend.
From the data and calculation, it is noticeable that when the colder water is added into the boiling water, the more time were needed to reboil. For example, when 125 milliliter of hot water was added into the water inside the pot, the time taken for the system to reboil was shorter than when 125 milliliter of ice were added. This is because the molecules of colder water move slower than the hot water. The water will slowly reach high temperature and will begin to reboil. However, hot water already possesses high temperature. Thus, shorter time taken were needed to reboil water in the pot. Entropy are influenced by temperature. From the result, the lower temperature of water added into boiling water, the greater entropy value for the system. The entropy of boiling water will always be positive. The heat released from flame heats up the surrounding and makes the entropy of the surrounding increase. Therefore, the entropy of the universe will also increase. This is why boiling experiment was a spontaneous process. One of the assumption of second law of thermodynamics can be explained in this result experiment is that heat will naturally flow from higher temperature body to lower temperature body. Heat cannot spontaneously flow from colder body to hotter body. Thus, more energy is needed for boiling colder water. In this experiment, the boiling water stops boiling when lower temperature is added into the boiling water. In this case, the lower body temperature was 125 milliliter of hot water, 125 milliliter of lukewarm water, 125 milliliter of cold water, and 125 milliliter of ice. The heat focuses on the molecules with lower temperature to balance out the temperature of the whole system. Throughout this experiment, each member were having differences in data obtained. The differences may be due to the different material and size of the pot initial and initial temperature of water source used for each member are also different. This is because every member only rely on materials and apparatus that are available in their houses. However, every member were having the same trend of data. This further explained when the experiment conducted, the lower temperature of water added into the boiling water, the longer time it is needed to reboil the whole system. The entropy for each member were also positive.
As for the conclusion, based on the experiment conducted, both of the objectives of this experiment are obtained, where it is to determine the time taken for water to reboil when added with water with different temperature, and to determine the change of entropy. Despite the differences of the data obtained, every member achieved the hypothesis made at the beginning of the experiment, where the higher the temperature of the added water into the boiled water in the pot, the lesser the time taken for water to reboil, and the larger the difference in the temperature between two waters, the larger the change in entropy. The experimental data supported the hypothesis, indicating the relation between the temperature of the added water into the boiled water in the pot and the time taken for the water to reboil in seconds. The lower the temperature of the water added to the boiling water, the longer it takes for it to reboil. Ice took the longest to reboil, followed by cold water, lukewarm water, and the shortest time for water to reboil is hot water. In the experiment, there were several precaution steps to avoid errors. The eye should be perpendicular to the measurement scale when measuring water volume to avoid parallax error. Consistency during experiment should be practiced when taking time for water to reboil. That is all. Thank you.